In this series of videos, we will take a look at graphing simple polynomials with the polynomials given in factored form. Factored form are the ones that you're looking at right now, that they're all in parentheses. Each parentheses will be considered as a factor. And if you know what a factor is, then you would also be able to tell where the roots are, okay? And if you know the roots, then you will also be able to tell the x-intercept. Now, they're closely related, but when you express them, make sure that you take special care of them. So for the first factor right here, we can tell that the root is -1 because -1 plus 1 will give you 0, and then 0 times all the things together will be just 0. Okay, for the second factor, we would know that the second root is going to be 1. And since we know that these are the roots, then we also know that they are also then we will know the x-intercepts, okay, at -1 comma 0 and 1 comma 0. And then for x minus 3, this particular factor, this would be a root of 3. Root of 3. That means your x-intercept would be at 3 comma 0. All right. So and then there's another easy part, which is to find out the y-intercept. Now, y-intercept, it's going to be a point, so please make sure that you express this intercept as a point, which means that you're going to have a coordinate pair. And what we know for sure about all kinds of y-intercept is that the x value must be 0, right? So therefore, we will put in 0 for x, and we just go ahead and find out what the value is going to be. Okay, so 1 times -1 times -3, which is +3. So somewhere here, we're going to go ahead and say this is 3. Okay, so easy stuff. Level 1 taken care of. Okay, 0 comma 3, got it. So at this point, you have your x-intercepts and your y-intercepts. Now I'm going to say this, and that is, there are 3 x-intercepts right here on the graph. I repeat, there are 3 x-intercepts. Okay, 3 x-intercepts on the graph. Okay, meaning that there will not be a fourth one, or there would not be one that is there, but somehow the graph doesn't touch. Now, it may sound a bit absurd to say, well, how can you have an extra one? Well, I'm saying this because I've seen it, how students, when they made a mistake and then they try to force their way to finish the graph, it's kind of weird. Okay, so all right, so let's keep going for now, and then I will come back to this particular statement one more time. Now, this next thing is to find out the degree and the leading coefficient, the sign of the leading coefficient. Now, the best way to accomplish this task is that I'm going to advise you to do this, okay? And that is, imagine that you are actually doing the FOIL process. Okay, imagine. And of course, it's kind of hard to imagine when you have more than 2 sets of parentheses, right? So what we can do is to just think about how the first term will inevitably multiply with each other. And then let's go ahead and write down what the first term it's going to be. In this case, the first term, it's going to be x cube, and that would give us the sign of leading coefficient, which is positive because you don't see a negative sign sitting in front of x cubed. And with that, we also know the degree, and the degree it's going to be 3. Okay, so now why is the degree and the leading coefficient important? Well, actually, we just want to know how the graph is going to start and how the graph is going to end. Now, there are more things to be considered here, but first we will say, let's go ahead and test something out real quick. And that is, if you think of the number -10, okay? If you think of the number -10 and put into this x right here, multiplying by itself 3 times, would it be a positive number or would it still be a negative number? Okay, -10 multiplied by itself 3 times. And you will find out that it should remain as a negative number because negative number multiplied by itself 3 times. So therefore, you know the graph is going to start low, okay? And then if you plug in 10 and then multiply by itself 3 times, you know it's going to be a big number. So it's going to be ending high. And this is something more about experience, and that is, if you see more of the polynomial functions, you will find out that whenever the degree is an odd number, they always start and end in opposite directions. And if the degree is an even number, they will start and end in the same side, in the same direction. Okay, of course, the reason would be just go ahead, plug in a negative 10 and 10. Then here you go. Okay, and just don't forget. Okay, don't forget that a graph, which is a line, right? It's a collection of points. All right, a graph, it's a collection of points. So to explain why a graph starts low, like this case, let me just go ahead and find out where the point is. And that's why we put in -10 for x. Then we have a good estimate. So it's going to go up. And then as we approach to this first root, now what you can see here for this particular question, you can see that the power, the exponent outside of the parentheses will all be 1, but it's not written out, so it's implied. So it means the multiplicity is just 1. So when the multiplicity is just 1, it's very straightforward. All you do is to make sure that the graph would simply pass through the root and then coming back down. There's no any kind of bouncing or special kind of turn. It's very normal, okay? Nothing strange happening. So yeah, if you happen to be perfect, then you are going to hit all those points with no strange, nothing strange happening, okay? So, excuse me. Okay, so I just took a pause. I went to I had a little bit of a cough. Sorry. So yes, so back to this graph. So if you happen to get a perfect graph, you should hit all the points. Okay, as I said, there should not be any problem. Now, what I want you to do is that I'm going to use this example to show you what happens if you just make a careless mistake. Okay, what's going to happen? Now, if you make one careless mistake, chances are you could still catch yourself. You just have to acknowledge that something is not right. Okay, like for example, if you somehow thought that the graph is going to start high, okay, and you still know that multiplicity of 1 means just passing straight through the roots or the x-intercepts. Then once you pass through the first root, you will realize that, wait, hold on, that's strange. I need to get back to my y-intercept. So if you recognize that something is weird, then you would just go back and double check. Now, what I don't want to see from you is that you made a mistake. Okay, sure, nobody wants it. But then you just kind of go with your way and say, "Oh, I'm just gonna go back up. I'm gonna cut the x-axis again." And this is why I made a comment earlier that there are only 3 x-intercepts, not 2, not 4, but just 3. It's this kind of thing that really caught my attention last year, that some students, because they want to go back to the y-intercept, they would blatantly cross the x-axis, okay, disregarding the fact that there are only 3 known x-intercepts, and artificially they created another one. That's kind of strange. So it's very important that you are aware of your own mistake. And if something turns out to be strange, I hope you can catch yourself. Okay. Overall, this portion, it's not that challenging. Okay. Just make sure that everything does mean something. The parentheses are factors. The exponent of the parentheses, they are known as multiplicity. And then you have this sign of leading coefficient to help you determine whether you start high or low. And the way you can determine it, it's by using what I would call it -10 and 10. Now that would be a really good way to tell whether you should start high or low without any kind of memorization. And the more you practice, the more fluent you become, very fluent after all. Okay, good.